Здравствуйте, друзья. Меня зовут Valentin Chernozemski, and I don't speak Russian, unfortunately. However, I speak English, and I would like to introduce myself. My name is Valentin Chernozemski. I'm 33. I've been working in the web hosting industry for the last 12 years, and that's a pretty long time. I don't know how do you found it, but web hosting industry as a whole is an entire field of different things. You got networking, you got services, you got hackers, you got crackers, you get storage, you get everything. And what I do in the hosting is to go for some food and fun. And in the spare time, when I'm not into the hosting thing, I try to get away from the computers and get some fun. I do skiing, snowboarding, surfing, anything. The further on the beach or in the mountain, the better. So that's what I like. But what I don't like in the hosting industry and in my job is to have problems. And in web hosting, as I told you already, we have a lot of problems. And one of the problems of a web hosting company is the security of our customers' websites. So we host websites. We are a web hosting company. And what happens to the websites if they are not patched? Okay, eventually they got hacked. You have SQL injections, you get brute force attacks, you have command executions, you get tons of vulnerabilities that are always being exploited by the crackers that are out there and by their botnets. So any hacked website leads to further problems. So this problem is spam, scam. I don't know if anybody of you have had a similar issue like those described here. Anybody? You don't have scam? Okay, I'm sure they have, but if they are on this presentation, yes. So customers' websites are generating problems if they are hacked because they are source of spam, scam, phishing, malware, and this leads to global sadness for our DevOps teams, for our system administrators, servers. And unfortunately, as you know already, there is no silver bullet to the website security, to the computer security at all. So what is the scale of the problem? We are a little hosting company, not that big. We have more than 12,000 servers and instances, and we are hosting more than 1 million of websites. I don't know how many of you host, but most of the websites, because we are general hosting, they are based on Drupal, WordPress, Magento, Joomla, and this makes more than 60% of the websites hosted in our infrastructure. And because we are a general web hosting service provider, we don't manage our customers' websites. They manage it on their own. So what kind of problem this brings? They install plugins. Nobody verified them. They hired a developer. Nobody knows his skill, how to write secure code or something like that. And there are websites running outdated versions of those plugins. So you subscribe just to Packetstorm. You write several lines of search, for example, for a WordPress plugin vulnerability. You found tons of those, and you can then Google Dork, and you can then hack into hundreds of websites. So those websites we measured are taking alone more than 120 million malicious hits per day on our website servers alone. So what we needed is to protect our customers from being hacked if we are not responsible for managing their website security. We are a hosting company, we give them the environment, they're in charge for the security, but in business it doesn't work like that. So we needed to reliably detect ongoing attacks towards our customers' websites and block them before they succeed, and before our customers' websites are breached and the other customers' websites are breached as well. What we also needed is, because we are a web hosting provider, people need to access those websites, is to avoid blocking legitimate requests. So we hope that this will make our customers happy and our servers happy and our DevOps team happy. And I don't want to bore you more with the story of our life in the web hosting industry. I'd like to present you the requirements of the system. So we have 1 million websites. The system has to be scalable, available, easy to maintain, easy to extend, and data center aware, because we have multiple data centers. Most of you do that. So you know what are the challenges behind that. So we built several layers that are required to build such systems, so we just outline them. Those are the attack detection, data collection, analysis, data distribution, and data visualization. So we can work out with the data to see how things are changing with the measures we apply, so you know how things are working. So we started with the attack detection. You can't block an attack if you don't know it's happening. So to detect if attack is happening, you have different services. So we have Apache, Nginx. Those are under attack, and you can detect and block attacks with mode security or Nginx Naxis module, Naxi. For services such as WordPress, Drupal, Magento, and Joomla, there is no such system available. So we have to build our component that detects brute force attacks against such websites and platforms. And we need to gather the data from such attacks and plug it into our data warehouse systems. So on site, we also have authorized logs of services such as FTP, SMTP, POP3, IMAP, SSH, and any bad failure attempt that is, for example, for an unsuccessful login to those services gets logged automatically. So you can have any service that generates logs of malicious activity. You can plug this service into the host stack, and the data just start flowing into your database, so you can later analyze that data. And when you have as much data as you need, you can analyze it and take decisions. For example, okay, this IP, for example, got a bad reputation. This IP got a good reputation. You know how these things are working. So the data collection, how many of you here are familiar with the ELK stack? Yeah, I guess that. So I will not bore you too much into the details. So the data collection layer looks very similar like that. So we have a FileBeat, we have a Logstash, we have Elasticsearch and Kibana. We will roughly go through each of these to see how it fits into our stack. So when you start with a FileBeat, what it does, every service, if we got back a little bit back, we can see that those services are generating logs. Those logs are filed to the server itself. So we need to get those logs and ship them on a central location. So FileBeat is a very simple program. It does one thing and does it very, very well. So it read lines, send them over the wire. You can do this in real time. And payload can be encrypted and should be encrypted if it's running on a public network, and even it's on your private network, it should be also encrypted. Ask Google if you don't trust me. So payload can be encrypted, signed, and authenticated. And what's the good thing about FileBeat is that if the other system that is receiving logs from FileBeat is down, for example, FileBeat has built-in exponential backup capability, which can say, okay, I got some lines to send you, you're down, okay, I'll try again later, until the logs are shipped or dropped. It depends on the configuration. So that's the log shipping part. The next thing is Logstash. Logstash consume JSON log files. So you get JSON generated by FileBeat, and you need to normalize that log so you can index it later into Elasticsearch. What you do is configure a Logstash and adjust him so it can consume different logs formatted, different logs generated by different services. You know that, for example, the FTP logs are not the same as the one generated by the SMTP logs. You know that SMTP logs are not the same as the one generated by Nginx logs and Apache logs. So they are all different. So what Logstash can do for you is to simply parse a log line that is shipped by FileBeat. They can split it into multiple parts. They can index it into different fields, and you can later send it as an output to a database. And the good thing is about Logstash that it supports multiple backends for storage. In our example, we are using Elasticsearch. So, but Logstash also supports Postgres, MySQL, files, or you name it. There is a lot of documentation on their website. So you also get all the logs that are generated from the pipeline. You have FileBeat here, Logstash that is splitting each log entry into indexed field. you need to store this data somewhere, and you need to be able to store huge amount of data reliably and with failover capabilities and high availability capabilities. And whenever you need to search for an IP address, if it's malicious or not, you need to query that huge amount of data. As a reminder for you, we have more than 12,000 servers. They are generating insane amount of logs. So Elasticsearch helps us to get those logs, the ones that are indexed and split it into chunks, and store them in a central location. Then we can easily query and get meaning of the vast amount of data that is written into it. Elasticsearch is highly available by design, fault tolerant by design, and as you know, you can query large data sets. And as most of you know, it is very, very much resource hungry. So if you have an SSD drive, it's better, you know that. So the next thing of our stack is Kibana. You don't need data for such a system if you cannot visualize what's happening with that data. It's just streaming of data. You can picture a word 1,000 words, you know that. So Kibana allows you to query this data that is stored in Elasticsearch and get us a meaning of the data. What are the attackers doing? Which are the main services they are attacking? What are the trends? And that's where Kibana steps in. So what we have built so far with this little stack is we have FileBit on top. Logs are shipped, encrypted, and authenticated to Logstars. Logstars split them into chunks, index different fields, and those fields are all logged into Elasticsearch. We can later visualize them with Kibana, and we can analyze them from Elasticsearch. So what we did is to collect all our logs in a central place. So the picture you are looking at is what we did when we started collecting the data. So you see for an interval of 24 hours roughly, we get more than 64 million brute force attacks against against services. Those services, those are failed login attempts to services. In this example, there are FTP, Exim, POP3, IMAP. I don't have such an example of the Magento Drupal websites because when I took this screenshot, the data was already long gone. So we don't store it for more than 30 days. So I took fresh data when we started implementing the services brute force protection. And you can see constant attacks. You can see the most brute force service here is Exim. It's getting a lot of attention from the brute forces because most probably they need to send spam. So the more email accounts they compromise, the better. The more spam they will be able to send. The next layer, it's the most boring one for me in this presentation, is the data analysis. So you have a bunch of IP addresses, data flowing through from 12,000 servers. You can do a little bit of scoring on top of that. For example, there is an IP address that is matching failed login attempts on multiple servers for a specific interval of time. So you write your own custom rules here. There is nothing particular. You can, for example, use artificial intelligence or neural networks. It depends really on your implementations. I will not go into too many details. You can only see, for example, in the previous slide, is that all the data is collected on a central place. So we do some analysis, and at the end, what matters here is that we're producing a list of IPs and networks that are that have very specific bad behavior, and they are attacking our customers and our networks, and we want to protect our customers from those IP addresses and from the malicious traffic they are generating. So what we need to do then is to distribute the entire blacklist we are generating to all our servers. We need to do this as fast as possible, because if there is an attack on one server towards our customers, I'm sure that the very same IP address will attempt to hit another customers of ours on another server. And remember, we have more than 1 million websites. And you bet it's happening. And the sooner you block the attack, the better for all the customers on all the servers, and the better for the servers themselves. Because the stacks we are using, the layers how we manage web servers, and how their websites requests are handled, the more malicious requests the attackers generate, the more overloaded the servers are. And this leads to slow customers' websites, overloaded servers, outages, and things like that. So we needed to distribute all those blacklists to all our servers as quickly as possible. And for example, how many of you are using SSH or SCP to distribute such data to their servers? Anyone? Puppet, Chef, Ansible? I guess that's correct. Okay. Who of you are using some other kind of system to distribute similar data? DNS, maybe? DNS block list? Okay, unfortunately, DNS block list doesn't work in our case because if each request that is for an image on a web server, for example, needs to go to a DNS query, it will be, all websites will be ridiculously slow. So what we started exploring is a tool called Consul. Anybody of you aware of this tool? Okay, a lot of people are aware of this tool. So how many of you are using actually Consul in production? It's very similar to the Docker thing, the previous year. So guys, Consul is a really awesome piece of engineering, especially for me. It's built on top of a tool called Surf. Surf was introduced on HighLoad several years ago by Michael Hashimoto. And Surf is a zombie apocalypse-like protocol for distributing messages in a cluster. So Consul took the idea of Surf and how good the messages are converging the entire network. And HashiCorp built additional tool on top of that network. So Consul allows system administrator and DevOps team to simplify service discovery inside their network. So you have a web server that is joining your network, and you need your load balancers to know about this web server, right? And how do you put this IP address of the web server that just was installed into the configuration of your load balancer? You need to know about this. So when you install a web server, actually you also start Consul on top of it and says, okay, I'm a new web server, I'm exporting service backend, and your load balancer can subscribe for such events and say, okay, I got a new web node over there. I can put its IP address in my configuration, and I can restart my configuration, which is okay. Immediately, traffic will be started forwarding to this node. It is the same with Elasticsearch. You know Elasticsearch, you will very often add new nodes in Elasticsearch because you are running out of capacity, out of IOPS, out of data storage. How your Logstash instances are knowing about the new Elasticsearch instances. So you do the same. You install Elasticsearch on one server, you install Consul on top of them, and it says, okay, I'm a new web node, I'm a new node, I have exporting service named Elasticsearch, and anybody that is interested in that service can act upon that. So it also simplifies service configuration because Consul have a built-in key value store. There are two modes of running Consul. One is the server mode, and the other is agent mode. And for example, you can put 5 nodes in your data center that are running in server mode, and those 5 nodes are starting servicing key value store with replication, failover, load balancing of reads across different servers. And you can use this key value store just like you use Redis. Unfortunately, the key value store of Consul is not that fast. You don't expect performance like Redis unless you put it, for example, its database on some kind of memory-based storage. On top of this key value store that Consul provides, you can achieve distributed locking, for example. My colleague over there, he mentioned that he has a tough problem where one node of particular row is master in his network setup, and the other node needs to be standby. This is a classic problem of the computer engineering. And you need to address which node should take over and when the other node should join in and step up as a master. So this node can hold a lock inside the console key value store and say, okay, I'm the master, I'm doing my job. And all of a sudden, this node fails. And the other, which is listening for the same lock, acquired the lock and becomes master. And even if this node is back online, this lock is already held. That can be easily achieved in console. I can later tell you a funny story if I have enough time. So one of the other things that console allows us is because you join all nodes in your infrastructure in a single cluster, that is the console cluster, is they are participating into the same messaging layer. And this messaging layer allows each node in your cluster to exchange messages. Okay, I'm web node 1, I just joined the cluster. Okay, I just saw that web node 2 is down, he left the cluster. And you have a central database, which is not so central, where everybody gets the messages. What's happening with the cluster, the system becomes dynamic. Everybody knows what's happening, and this is done thankfully to the gossip protocol that is implemented in console. And it also allows us to use our entire data center as a database. There is no need to have a MySQL Postgre where you write statuses of all your services and what their status is and what's going on with this node. Okay, I should update the configuration of the other node and put this in Postgres on MySQL. Console can answer to that question. All this data is also very easy to query. You can do it through HTTP, you can do it through DNS, you can do it with a console built-in CLI tool. You can use curl, dig, hosts. It depends. Console exports several catalogs. Several things. It exports the service catalog. It exports the key value store. And it exports the messaging layer to all the participants of the cluster. But what about the security? So console is written in Go. It has a clear threat model written on their web page. All the communication is encrypted with pre-shared key. All nodes that are part of the cluster are authenticated with signed SSL certificates. And each node that is participating into your cluster, it has its own token. And the good thing is that each token can have a specific set of rights to each of the code catalogs that console is exporting. It's very similar to the Unix permissions, but not like that. So if there is a catalog endpoint, and there are certain nodes that should see, for example, the database nodes, if your token allows that, you can see the database web nodes joining and parting the cluster. If your token is not allowed to see that, you cannot see that there is even database node. You don't have permissions to see that. It's a good thing, security. You know security. Yeah, console doesn't require extra privileges. It's 2017, it's ridiculous to run as root. So it's quite scalable, I guess. The server part, you can, for example, install 5 console servers into one of your DCs. They're dealing between them based on the RAF protocol, which has a built-in failover. If you have too many reads to the console node, to the console servers, these reads can be either ACID or can be stale reads. So if you need an ACID read, all the reads are going to your master. But if you are okay with the stale reads, you can disperse all your reads to the other slave servers to which console server is acting as a slave, which offloads reads from the master node. And you can achieve more read throughput. It is data center aware. For example, my web node in Chicago can know if a database server in, for example, in Singapore is failing, if I need to do that, or the vice versa. For example, my Amsterdam data center might know that my central database in the Chicago is down. So, and the messages that are exchanged by console, they're based on UDP, and they are very, very low overhead. You can actually calculate, depending on the size of the cluster you have, for how many time the message will converge all the members of the cluster. And the more interesting thing is that you can actually calculate how many bandwidth it will consume, which is great. It's predictable. It's not like a broadcast. It's not a broadcast. It's based on gossip. You check the paper, you'll see what I mean. So consul is reactive. As I already know, I already told you, there are different catalogs, and you can subscribe to events. It's like the PubSub mechanism. You have a key value prefix. You can set up on top of, watch on top of it. Anything changes in this key value prefix, you can do certain actions. For example, if I would like to reload Nginx instances on all nodes, I would just write one into /row/nginx/reload. And this will trigger all members that are watching the particular key value prefix. Okay, somebody told me to reload my Nginx. Okay, I'm doing that. So it can be used for orchestration. You can set a watch per key or per prefix. For example, if we write all IP addresses that we generated as bad behaving IP addresses in my previous slides in /row/ipset/blocked, all the nodes that are subscribed to this prefix can see that a new IP address has been banned, and it needs to act on top of it. So we got IP address 1234 that is brute forcing. I immediately write it into this prefix. Any machine that is subscribed to this prefix can immediately ban this IP address on it locally. You can also set up service watches. I already explained. If there is a web server that needs to query a database server and master database suddenly failed and changed the IP address, you can immediately change the IP address of the database in your web application configuration. Okay, server Hicks just failed. This is the IP address of the new server, and you just swap it in your configuration, and your website continue to run. No need somebody to call you at 12 p.m. to tell you that failed or didn't work. Happened to most of you, I guess, or at least to me. I don't know. The good thing is also that you can also run local checks and see if a particular service is, not only that a node is failing, but the check for the particular service that is running locally is failing. So it gives you even better control how you detect that certain application isn't performing well or it's down, for example, core dump. You can set up node watches. For example, tell me if server Hicks is failing, send me a pager duty. And there are also event watches, which are, as I already mentioned, that are, those events are based on gossip protocol. The bad thing for the consul and the gossip events are that the payload is limited to 150 bytes, which is not much, at least for our case. But if you have just an event name and not that big payload, you can distribute those messages across your network very quickly. So yeah, consul is production ready. As I already said, it can be queried via common tools, HTTP, CLI, dig, curl, you name it. Documentation is awesome. It's evolving very, very quickly. And it doesn't replace systems such as Ansible, Puppet, Chef. It doesn't replace them. It's not there to replace them. It's there to make your infrastructure more reactive to changes. Nowadays, we don't build highly scalable and highly available systems. Nowadays, we are building systems that are actually reacting on failures and that can tolerate failures. So this thing is helping you to make your system reactive and act upon events as they happen. Our cluster size is almost 2,000 nodes. It's not 12,000 because we are installing consul on top of the host nodes we are running. So the 12,000 machines we got, there are VMs, there are containers, there are bare metal machines. But we are installing consul only on the bare metal servers. We don't need it on the virtual machines or the containers. We have DCs that are joined in a consul 1 wide array network, and it's handling just fine. So one other awesome piece of engineering that guys from the HashiCorp wrote is consul replicate. You have a master DC, for example, Chicago here, and you write some data. into each key value store. And you need the very same data to be asynchronously available in your Singapore data center. How do you do that? With this thing, it is very, very simple. No need of very complicated configuration. You just say, hey, this is my consul master server. I want this data to be replicated from Chicago over to Singapore. And that's what it does. It's installed on all our consul servers, and high availability is handled with the consul lock. I already told you about it. So you're just starting it, consul lock, consul replicate /pub to this DC, and all the data start pouring into the local consul servers. You never replicate the entire slash of the consul key value store. There are reasons for that. And what are the awesome tool that the guys wrote is consul template. So consul template, what it does is it reads from the catalogs I already told you about. There is the service catalog, the key value catalog. You tell it what to read from that catalog, and it renders it in a specific, and it renders the changes on disk as they happen. So if, for example, I have a web load balancer that is interested in backend web servers, and we see that a backend server fails, we can say, okay, I have this template format. I need to know whenever backend server fail, I need the IP addresses of the backend server. As soon as the backend server fails, it rewrites the configuration. You tell it to write, and you can tell him, for example, to reload the server. So backend server fails, IP address is removed from Nginx, Nginx is reloaded. We does that for FileBit. FileBit is sending data to Logstash. We already talked about that. And we have different Logstash instances that are enriching the data we are sending from our servers. So consul template is rendering etc FileBit YAML configuration on all nodes that are collecting data. And as soon as a Logstash pops in or falls out of the cluster, it rewrites the configuration and reload FileBit. So we can be sure that data is sent only to healthy nodes. There is no need to attempt to send data to nodes that are failed already. And this allows us to dynamically add Logstash instances. Whenever we run out of Logstash capacity, we just install one node. All the services that are subscribed to listen for FileBit for Logstash instances get the new configuration immediately. And that's the role of consul template in service discovery. Those are just the examples which files we are rendering. So I already told you about that we subscribe for Logstash instances. We also, on the Logstash nodes, subscribe for new Elasticsearch index nodes. And because our web protection system works by redirecting malicious requests to capture servers, those capture servers need to be also, we need to also dynamically add those capture servers to our configuration. So if the capture servers are overloaded, we add a new capture server, and all Nginx nodes are getting the new capture configuration. We also exploit consul template for key value distribution of the IP set and Nginx blacklist configuration files. So we get all the data of the IP addresses that are brute forced in our services into applications. We write them into the consul key value store, and anytime a new IP address pops in, it's automatically distributed to all the nodes of the cluster, almost 2,000. It's the same for the Nginx blacklist conf. So anybody of you knows what IPset does? IPset? Okay, it's like IP tables but faster. Way faster. Yeah, you should be using that. I don't know how many of you have tried to put like 10,000 rules in IP tables. Anybody of you try that? Is it slow? Just a little bit. And the more IPs you are adding, the worse it gets. So yeah, that's what we do. We get all of the IP addresses that are bad behaving, we put them into the consul key value store, and those IP addresses are immediately appearing on the servers where this should be filtered. So they are rendered on the disk, and the console template allows us to run post hooks after each render, which allows us to add each IP address into the active IP set configuration as well. Because it's not very good to restart Nginx anytime you add a new IP address, we actually do it like every 60 seconds. We are reloading Nginx, because Nginx is an awesome piece of software engineering. It works very, very well, and nobody notices the reloads. So that's how the console stack looks like. You have one data center. For example, I label it master data center in Chicago. This data center has a console key value store. It has a service catalog of all nodes that are participating into the Chicago cluster. I have console replicate that is copying our data to the other data center. It's asynchronous. And I also have the key value that was written in Chicago in Amsterdam. The console service catalog, however, is per data center. So Amsterdam knows that there are, for example, 100 web nodes there, and Chicago knows that there are 100 web nodes there. But if I ask for all the web nodes, I get 200 web nodes. So I have a global service catalog. What's happening with my cluster? So yeah, and console template is client to console key value store and console service catalog, and it's rendering the specific configuration files that are listed here. So you might be wondering what are the results after we started implementing this in our network. The results are like that. This is the entire diagram that shows the architecture of the stack. It might be complicated, it might be not. For me, it took us a while to build it. But this is how the entire thing looks like if you're interested. You can find the slides later. And we have more than 12,000 servers protected, more than 1 million websites protected. Global attack detection latency is, for example, for about 5 seconds. For Nginx, it's like 60 seconds by design, because it's not good to constantly reloading Nginx, even the reload mechanism works good. And what happened with the results? We are filtering more than 120 million malicious web requests per day. That makes 3 billion filtered web requests per month. And those all are requests for hacking WordPress, Drupal, Magento web applications, maybe even others, because you have an IP address with bad reputation. It's not like I'm hacking WordPress only. I'm hacking anything I can. So those are the number of web requests that are filtered for 24 hours, 7 days, 30 days. And this is how the picture looks like. But if you look closer to the picture, the green thing is not the brute force attacks. It's actually the filtered web requests. The brute force attacks are the tiny blue dots on top of the green thing. So you get the idea of how many requests are malicious and how many requests are actually reaching our servers. You get the numbers on the left and on the right side. On the left, you see the filtered requests, and on the right side, you have the number of requests that are actually reached the server. And this is from the entire infrastructure. So the previous slide was for WordPress, Drupal, Magento, Joomla. Those are the results for the services, the FTP one, the IMAP one, the POP3. When you install this system, the rate of failed login attempts to those services dropped dramatically. At the end of the slide, you can see how many failed logins are there per second, per service, per domain on our servers. So in security, you know that you cannot achieve perfect security. You need to do as many layers as possible of security so you can slow down the attacker in a way so that the attack doesn't count for it anymore. So you get the cryptography, you can break the chipper, but you'll be dead by now. So it's very similar thing with the brute force. So this is how the system looked like after it was implemented. Actually, I was able to take a screenshot. So you can see the drop, the malicious failed logins as soon as we started the system on all our servers. So I don't know if it's interesting to you, but for me, it's nice. It works. It does the job done. So what's so cool about this system? The system is scalable, available, fault tolerant, self-assembled. It's event-based. which is, for me, it's the most beautiful thing. It's based on events, so you get this thing plugged and everybody knows about it. There is no need for manual configuration, things like that. It's most important, it's very, very easy to manage to that extent. You can always plug another component in this system. So some notes as a for almost end of the presentation. This should be the old version, yes. We can make the system real time. We didn't do that yet. At the beginning, it was not designed to be a real-time system, but we can do this. We can plug more Logstash instances, more Elasticsearch nodes. We can fiddle a little bit with FileBit, and it will be almost real-time. I wish I will plug more sensors into this system, because we are responsible for 1 million websites, and we want those websites to remain as secure as possible. And anytime in my system I can sniff the attacker, I'll find him and I'll block him. That's what I want. I don't want attackers on my network. You don't want attackers either. So we want to block attackers earlier, but we already do that. I told you that we are actually blocking on each host node. Unfortunately, our data center doesn't allow us to block on edge routers, which would be awesome, actually. And I really want to do block list sharing. Anybody of you are sharing their block lists with external providers or exchanging block list information? Anybody of you do that? Okay, we can talk later, like, or no. And yeah, I really want, I don't have much time, but it will take 5 more minutes. I recently read an article where the attack should not be stopped at the end of the attack. It should be stopped as close as possible to the attack source. I don't want the attack blocked on my end when it reached our network. I want the attack stopped at the ISP from which the attack originated. Why I should handle malicious traffic? If I know that the traffic is malicious and I can tell a guy ISP, okay, this IP is full of viruses, this website is hacked and generates malicious attempts, why don't you block it? Why should it be on my network? And that's what I want. I want to exchange data with as much possible ISPs, so whenever such a traffic, whenever traffic is detected from a malicious IP address, so their ISP is responsible for blocking that traffic and taking measures. But it is internet, and I don't believe it's going to happen. It's not. Yeah. Some footnotes. Additionally, FileBit real-time work shipping configuration is not so straightforward to be implemented. The documentation is a bit cryptic to me. I checked it like 50 times. I almost did it, so FileBit can ship the logs in real time. Anybody of you is doing FileBit in real time? Okay. As you know, Elasticsearch is feeling much better on SSD drives. The more IOPS, the better. When you're installing consul on your nodes, you should know it's a good idea to label those nodes with the services they are exporting. In consul, you can say, okay, this is the node I just installed. It exports, for example, service FTP, service SMTP, service IMAP. And those services are immediately available in the consul catalog. So, for example, if you have a server.com, you know that server.com is a hosting node. And hosting node, as a role, exports those 3 services. And it's a good thing because you can later query these services in your consul catalog. I already told you that consul event payload is size limited, and consul key value payload is limited to like 5 megabytes, but it works. And you should beware of the ARP traffic with default Linux configuration if consul agents are into the same subnet. So you should better check, if you're planning to install consul in your network at a wide scale, you should definitely check this video out before you do this on 2000 nodes. It's like, yeah, shit are happening all the time. So, yeah, you can take a photo. I can give you the word. This video is actually from the good guys at DigitalOcean. and they had a problem, and we had the same problem. We'll watch the video later. So if you are planning to do that, you better watch the video now. So why we don't do this and use that? Security is a tough process. This particular system fits our bills, and security is expensive. That's why we decided to implement it this way. I'm sure you are doing it, guys, much better. I would love to hear about that. There are companies, Curator, Cloudflare, Security, that are offering such services. We are not fighting them. Our system is just an add-in to their services. Our customers are happily using all of those, and we are the last frontier before they hit our servers. So, yeah, questions?
Yeah, we have time for 1-2 small questions.
Okay.
Один-два вопроса. Я где-то здесь видел первую руку.
Hello, my name is Alex. My English is not so perfect as yours, but
I
want to
awesome.
try. Thank you. But I want to try to ask you some questions. First question about console. You have a big key-value store in console, for example, blacklist. You said.
Yes.
Do you have any persistence for the store? Maybe nightly backups.
Yeah, there is another awesome tool that is called console backup, which allows us to take backup of the key value store with a single command, and it does snapshot wherever you take. You can STP it anywhere you want. And also there is a persistent of the store. We actually, the console database is backed on drives, these drives, but if you need really to be able to fast persistence, you better put it on SSDs.
Okay.
Or if you don't care for persistence, just put it in the RAM, it's okay.
Thank you. And the question, second question is about engines. You said you have a delay by design, 60 seconds. Do you know heard about HA proxy? Console template with HA proxy, you don't have this delay.
Yes, we heard about it, but our software stack and the whole hosting stack is so maybe complicated, maybe not. It's built like, let's say it's built that way, and we don't want to put more layers. It works for us. It's okay. We can build it faster. Yes, HA proxy will do the trick, but just the specific setup of our servers doesn't allow us to do that. Yes, we can actually do this, but it's just a bit a lot of overhead. So.
Okay, thank you.
Hello, I have two questions. First question, do you have timeouts for your IPset block? Second question, how do you manage all clients behind the Cloudflare if they are under attack and this attack are proxy to you? Do you block Cloudflare IPs? Do you block header from Cloudflare IP, or you just ignore this?
I can immediately answer to that question. Of course, we're expiring blocks. We know there is no need to block the entire internet. We're expiring after 24 hours, and the most common an IP address is the longest the block is. For example, it starts with 24 hours, then 48, and things like that. For the Cloudflare IPs, we know their networks. They are publicly available, and we adjust a configuration that allows us to trust the proxy header they are passing to our servers. And whenever we see a request from their IP networks, we actually read the Hix-real IP, and that's what we block. We don't block the Cloudflare IP addresses. We block the Hix-484 header they are passing to us. So does this answer your question?
Это был последний вопрос, потому что у нас совсем не остается времени. Вы еще можете найти Валентина в залах и позадавать ему вопросы. So, thank you, Valentin.
Thank you for your time, guys.